So hi everybody. We are going to be talking about micro. This is very neat. I like micro. Okay. So first of all, actually, I want to ask: does everyone here know what micro is?
I don't know the difference between micro and macro.
Okay, actually, very quickly. First of all, what does everybody think that economics is?
The study of how you pull the wool over the eyes of the proletariat and justify the horrendous capitalist exploitation.
I like Kiki's answer. Mighty Hunter Go Brr.
I mean, the study of how production is coordinated within our society.
That is one possible answer. My uh, maybe. So the answer that is most commonly given in economics classes is basically it's about how to allocate um, resources, or specifically scarce resources. So basically, like, what do you like? You have a certain amount of stuff, and you have to figure out sort of how to use this stuff to get things that you want. The study of how sexy Ricardo is. That is a great answer, especially because there's a double meaning of Ricardo there. Um, so there is essentially that is the standard answer that's given. I like this answer, but then somebody pointed out to me that money is like basically not scarce because you can print it, and I went, "Oh fuck! I need to find another answer." And then the answer that I think probably gives it best is that it's the study of trade-offs. Really, it's just like how do you trade things off against each other? Like, what do you do when you have to make choices between different things? And that is mostly what we're going to be talking about, like how you make efficient trade-offs, how you pick the right option, and essentially how to make things really more efficient. How do you make efficient trade-offs is the big thing. Um, so that is probably what I would go with in terms of that being the best answer. What we're really going to be studying, especially in a microeconomics class. Really, the big difference between a micro and a macro is going to be that in a micro class, the majority um, of stuff that you're talking about is going to be sort of individual actors based models. So you are basically studying everything from the perspective of how do you figure out like what is going to happen based on how individuals are going to act. How is a company going to make hiring decisions, for example? How is a company going to try to maximize its profits, and things like that are going to be the main things that you're going to be talking about in a micro class. Albeit somebody yeah, so that's the big thing that sets apart micro from macro. In a macro class, you are generally going to be talking about things like how does the economy as a whole work? How do we try to minimize unemployment? How do we try to control inflation? And those are different questions from the ones that we're probably mostly going to be talking about right now. Although microeconomics does bring a lot to bear on macroeconomics. There's a lot that you can learn. There's a lot in macro that is based on what are called microeconomic foundations, essentially trying to build up how the economy will work from these individual actors, because that really is like a lot of what economists want to do. I don't just want to know, is the relation something between them something like chemistry and biology? So what do you mean by that, Kikis? Biology is made of chemistry.
Well, yeah,
So
but there are parts of biology that are almost entirely autonomous from the study of chemistry, so I don't think that that's a great analogy.
yeah, there's the other thing is that I would say that there are parts of macroeconomics that do have like this a relationship that you can describe in this way. I think that there are parts of macroeconomics where you essentially try to build agents-based models, based on individual actors, like how are people going to act. But it's not necessarily all of macroeconomics is like that. Sometimes you'll just say, okay, I've seen
I
this
think it's something about
observed regularity in
transfer of
some
wealth.
data that I have. I don't care where it comes from. I'm just going to try to like work with this as an assumption and see where it leads me. And you can do that instead. Another thing is that yes, we're a real science.
Yeah.
Please don't.
Jim's groceries. Should I split them equally between the two of you, or should I send them all via splitwise to Jim or to you or something else?
We haven't discussed that yet. Sorry.
Right.
I'll message later.
Great.
It sounds like an econ question.
It does. Yes.
Making decisions about splitting groceries, that's microeconomic, right?
That, I mean, I think that would actually be. That is actually a Syacne. Yes, it's a real Syacne. That's how scientific we are. That I don't know how to spell science.
Oh wait, does
So we get-
Discord have like hold to speak?
It has push to talk,
Sorry.
yeah.
Yeah, it has push to talk. Okay, I'm going
Yeah.
to mute that and then turn on push to talk.
We also know on the inside that we're not. Okay, so I think that mostly what this class that we're going to be talking about, for the most part, is going to be really. I think that we're going to go over production possibilities, frontiers, and a little bit of utility maximization, which are really going to be the bread and butter of this microeconomics class. So the first thing, so the first thing that we're going to talk about is something called a production possibilities frontier. Has anyone heard of these before? No. Okay. So a production's, oh god, that's terrible. Let's see. Yeah, I made a right angle. That's I've peaked in life. This is the best thing I will ever do. So, the main thing... Oh, RB, do you have a question? Oh, by the way, can you all see my screen? Right now, because I only see 11 people on the... Ah, okay. Leo, click on my name. Oh, I am using... Hold on, what's it called? GoodNotes. It's an app on my iPad. So... Yes, you will be able to, Crow. Oh, can you hear me? Okay. I will be uploading the handwriting also to YouTube, so that everyone can see it. Okay, so the main thing is possibility production possibilities frontier. Okay, PPF. Despite the name, it is not actually a really bad euphemism. So the thing that a PPF is, and the other name that we have for it is a budget constraint. Why did it try to turn the B into a budget constraint? And essentially, what the idea is that you have a set of points that like are possible. Like let's say you have two goods. Does somebody want to provide an example of two random goods? Anything?
Bananas
Coats
and
and
apples.
mangoes. Okay, perfect. That means that we're going to go with guns and butter, because I'm going to ignore you. Guns, but I ran out of space, so we're just going to have to do with guns and butt instead. Medical tests. Okay. So the idea is that there's imagine that you're sort of like stuck trying to make one of two possible goods. You're either making guns or butter, which in the original example was sort of meant to be a trade-off between civilian and military goods. Like, you can either devote some amount of money to... Yes, exactly. We're sort of like, let's imagine that we have like a factory that can make one or the other, but not both. Something like that. We have like a certain amount of space in a factory. Because the thing is that the factory has or really, it doesn't have to be a factor. We can also think of this as just an economy. And in fact, with like the idea of a guns butter trade-off, that's usually going to be what you're imagining. And so you can't make like if we could make an infinite amount of guns and butter, we would like to do that. That would be great. Actually, an infinite amount of guns and butter would like probably collapse the Earth into a black hole or something. Yeah. We actually, so that's the thing, where's shoes? So there's not necessarily a way to just maximize output so much as we are imagining a certain set of points. Like, let's say that maybe you can have 10 pounds of butter and 10 guns here, right? And that's like one possible point, because that's one way that you could make that you could use the economy to produce a certain amount of goods. Like 10 guns and 10 butter. That's one thing that you could do if you wanted to. Another thing that you could do maybe is like, let's say 15 guns and 5 butter. That's another thing that you could do. Like, you could have, for example, some workers like switch to making guns instead of butter. Or you could do the opposite. You could have less guns and
Sorry,
sort of, well, yeah.
are we assuming here that guns and butter trade off against each other exactly?
Not necessarily exactly. We could do that if we want to. Actually, okay, so we could have the assumption, like if we wanted to, that like the amount of guns plus butter is going to be equal to 10, for example, or let's say 20. And then we could have 10 and 10, or we could have 15 and 5, or we could have like that, any point like that. And then we would have like a straight line, right?
Mm-hmm.
And that would be one possible thing that we could do if we wanted to.
Yes.
And that is actually, okay, so that would be one example of a production possibilities frontier. Essentially, these are all of the, what are called the feasible points. All of the points that you could actually feasibly get. And then what we're going to have is some points are going to be in here, for example. And these are what we're going to call productively inefficient. It's trying to.
So can I get
This is amazing.
question in?
Sure.
Because, well, is it like a guns and butter is like the standard example, or is it?
Yes.
Yeah, because I just looked it up on Wikipedia, and it's also the example they used. So this was
Exactly.
a bit weird. But I mean.
Yeah. The standard example is it comes from, I believe it comes from the military-industrial complex speech that Eisenhower gave, where he gave the example of producing either guns or butter, and the idea of just a guns and butter trade-off.
Right. But I mean, essentially,
It
the
would
idea is
look like
just we
We'll get to that.
could produce like so many guns and so many butter, and we are trying to figure out which ratio or which amount of guns and butter is going to give us the most bang for the buck, so to speak.
Yes, that is one thing that you could talk about. Exactly. So, essentially, what we have here, the guns versus butter trade-off is supposed to be a trade-off of, like, civilian butter and defense goods, like guns. So, that is valid. Where she's mentioned that she thinks only guns produce bang and butter doesn't produce any bang for any amount of buck.
Quoted
I mean, if you drop the butter
by
from very
Joseph
high.
Goebbels.
That's the perfect follow-up. Oh my god, I wish I'd come up with that.
It's wonderful.
Butter is useful for banging, though.
Sorry, what was the joke there? I missed it.
Leotol mentioned that butter is useful for banging, though.
Well, no, it's food. It's gonna go moldy. You don't want to use food in sex.
There's a famous scene in a movie.
I mean, you wouldn't want to use guns for sex either, I think.
On king shape.
Disagree. I think that's hot.
Yeah, that's. I think that is literally. I think that's like how Donald Trump works.
It's sad that one hasn't gone off yet.
Okay, so we're going to talk about 3 different sets of points. So the points on the PPF essentially are what we're going to call productively efficient. So these are good points. Like we like these points that we can get because they're points where you're producing the maximum amount of you can. And there's also productively inefficient points. There are points here. Like for example, here we could have let's label it red so you know it's bad. This is an inefficient point because you could produce instead here, and then you would have more guns and more butter. And then you're also going to have points on the outside of the production possibilities frontier, which are called unattainable. They're just not possible. It's like this region is the only region you can produce, and you always want to be on the efficient frontier, producing as much stuff as you can. And mostly, though, the task of how you get to the efficient frontier is one for macroeconomics. So instead of going to stick on to talking about trade-offs at the efficient frontier, we're assuming that like everything is being used. Like for example, everyone has a job, or the factories are always on, or things like that. And then we're going to talk about like how to make trade-offs. Macro is the subject that's going to talk more about how to get to that point. So the things, okay, so the questions that were being asked. So Prof, you skipped ahead, but you actually did point something out that is perfect, which is the PPF does not actually have to be a straight line. In fact, it will almost never be a straight. In fact, it will literally never be a straight line. That has like measure 0, because that would just be like an absurd, like to say that the amount of guns and butter you have adds up to a precise number, and this never changes, is sort of a bit of an absurd model that you're not actually going to get. You can also have like a curved frontier that looks like this instead, or you could even have one that looks like this, although we're going to talk about nobody make a joke about that shape. So what we're going to have is you can have a concave or a convex production possibilities frontier instead if you want. So this is like a concave one. It's bowed out, also it's called. And essentially what this means is that you are getting a...
Is there like a quick 5-second reason why the PPF is never going to be a just plain linear equation?
Simply because there's so many things. There's like an infinite number of shapes that it could be, right?
Right.
Like it could be any possible shape.
Oh, right. Okay.
So
So just sort of in the universe of all possible relationship
all
between
possible
guns and butter, it's just infinitesimally unlikely to be.
Well, I mean, it is
To be a
going
straight
to be
line.
a linear line. If you instead of looking at guns and butter, you look at guns and guns, then it's going to be a straight line. Well, I mean, if material is I think. So anyway, it's not. I mean, yeah.
You're not wrong. You're right. Why are you laughing at me? I'm right.
If you have a nice voice, by the way.
Sorry?
I just told Yves that he has a nice voice, but I guess we should keep on. Go on.
Yes. Yeah, it was... it was... Okay, so... Then in this case, we would not have them adding up to a single nice number. And then this also has like a... when it's not linear, a nice interpretation. Essentially, the idea is that there are some resources that are very useful for producing guns, but not at all useful for producing butter, and vice versa. For example, a cow is going to be completely and utterly useless for
Boo!
producing guns. You can't use it for that, or at least you can't use it efficiently. Like, you would have to make it, like, pull a water wheel to power a factory or some bullshit like that. Bullshit. I'm making too many bad puns.
You could use the bone to make gun stocks.
Yes, exactly. So you could theoretically do it. It's just that it's going to be very inefficient. So the idea is, like, as you produce more guns, as you go, like, up this PPF, what's going to happen is it's going to get less and less efficient. In fact, like, this is why I asked you to read about derivatives. So then that's a terrible tangent line, but it's my best attempt. So then the tangent line, when you think about it, sort of is going to represent how many guns you're trading off for how much better, right? Does that make sense to everyone?
Mm-hmm.
Yeah, okay, so, like, for example, with the slope of this line means that for, like, if, let's say that the slope is 2, then that means that you are getting 2 guns for every butter that you give up at this point. So then in that case, that's what sort of the opportunity cost is. And then you could also have so then as you go up, then the interpretation is that you're getting less and less efficient. You're trading off more butter and getting less guns. Like, up here, it might instead of 2, it might be 0.1 or whatever it is. And eventually it might even get, like, completely flat. Like, at some point, you just cannot use this resource physically to make guns. It's just, you're trading off in a completely useless way. And the same happens here. Like, as you go lower, it becomes steeper because you're trying to use some resources that just are not useful for butter to produce butter. You could, though, also theoretically have a bowed-in PPF. This is a lie that they tell to undergrads, that you can't have a bowed-in PPF. Well, that's the argument that's sometimes made is you can't have, like, so you can't have a bowed-in PPF. You can't have a concave PPF, one that's shaped like this, that's going in. And this is a lie they tell to undergrads, and they say the reason why is because as you're going to switch always the most efficient resources first. That you're going to, like, use the cows last when you're moving from producing butter to producing guns. But the thing is, you can have a bowed-in PPF as long as what's important is you have to have very big economies of scale. Essentially, when you switch to producing guns, as you produce more guns, then you can do, for example, you can build a large factory, whereas before we had a small factory that just had, like, one worker in it who was trying to, like, buy all of the parts individually and just putting them together by hand.
So is this essentially an economies of scale thing?
Yes, exactly. It's economies of scale. Like, if you have strong economies of scale, it can be possible for you to have a bowed-in PPF. Where as you produce more guns, it becomes more efficient to produce even larger quantities of guns, because you get these economies of scale. You can buy machines so that you can make a whole bunch of guns. So really it can have any shape that you want, either concave or convex or straight line. Although, as mentioned, that's unlikely for 2 different goods. So you have that. So, like I mentioned, this is called a PPF when you're talking about sort of an economy. When you're talking about a particular person, it's called a budget constraint. So, for example, if instead of having guns and butter, we had what was the suggestion? Coats and mangoes, right? Like for example, you could say that the number of I'm just going to start a new page. That the number of actually I'm not going to do it, but like you have, for example, $20 and you can spend it either on coats or on mangoes, and there's like, for example, you could have $5 of coats. $5 for a coat and $10 for mangoes, which would be an insane system of prices, but then you would have to have your budget, the total amount of money that you're spending, add up to however much your income is. And that would be when you would call it a budget constraint instead of PPF. So now what we're going to... Okay, so any questions so far?
9.
9? Okay. Does that mean you have 9 questions or that you have no questions?
I have 9. I have 9, but I'm a Nazi.
I don't think we can have Nazis in this.
I was trying to make a joke about the Nazi economy, but it just wasn't coming to me.
Who wants to make the joke? This was where the Nazi economy was produced. Right here. All of the guns, none of the butter.
Yes, there we are. I wasn't looking at the graph at the time, sue me.
CLC, that's Hitlerious.
Fuck you!
Fuck you.
That is terrible.
Actually, yeah, that's actually completely correct. Where she's added a quote here. Hermann Goering announced in a speech, "Guns will make us powerful, butter will only make us fit." Which is amazing given Goering's well known for being very fat.
So what is all of this useful for? I'd like to carry on. So what's next thing?
Okay, so now the next thing is, now we're going to talk about indifference curves. So let's say that John is trying to decide whether to buy, like how much of 2 different goods to buy. So we can have coats and mangoes. Coats, mango. So, as mentioned, he has some sort of budget constraint, like some amount of money that he can spend, right? So let's draw a line. There you go. And now we're going to talk about the concept of an indifference curve. So the idea is then John is not completely indifferent between all sets of options. There are some sets of options that John would prefer to have. Like John might prefer to eat, he might prefer, let's say, okay, so let's say that John is, let's say that the number of mangoes and such that John has is here right now. And let's say then that John would prefer this bundle of goods over here, with fewer mangoes but more coats, right? So then we can ask John, basically, what are all of the sets of goods that you would prefer to this current set that you have, that we've picked out? This is the current set of goods, right? Yes, that is an infeasible point that I've highlighted. That is a point that he would prefer, but it's not possible. So then we can sort of map out, like asking John, okay, what region, what sort of like sets, what bundles of goods, like what pairs of coats and mangoes would you prefer? Which ones would you say are better? And John might say something like, oh, okay, well, I would like everything that is in this region here to the right. All of these would be better, and anything to the left would be worse. I would not like be willing to switch to that bundle of goods. So then, in that case, what we have is this curve here in the middle, the place where he is completely indifferent, where he doesn't care, is called an indifference curve. Yes, wears shoes, that is correct. Anything on the PPF is what's called Pareto optimal, which means that essentially you can't get more of one good without giving up some of the other. And so what you'll see then is that, like, on this, so yeah, this is John's indifference curve, which is starting to get ugly, so let's erase some things. And what we can sort of imagine is that John then will have infinitely many indifference curves, right? Like this curve, and this curve, and this curve. And as you're going outwards, essentially, what you can imagine is that each of these curves is preferred. Like, for example, this curve here, so let's label this one U0, let's enable this one U1 and this one U2. And as he's going outwards, like, each of these indifference curves is preferred to the last one. Any questions so far, or are you all getting
That
this?
makes sense.
Yes. So now, actually, Mond, because you know some more math, what do you think we can build from this idea of infinitely many level curves where there's no preferences between points on the indifference curve? Oh, Basil. Okay, so the idea is that it is an indifference curve because on each one of these indifference curves, the consumer, John, is, like, completely indifferent. He doesn't care which of these bundles of goods he gets. It's just like, who gives a shit is his answer. But then some of these indifference curves are better. Essentially, these indifference curves are like the set of points that he doesn't care which one is better. Yes, exactly. But not the other curves. So then, the thing is, though, hookers and blow would have been a great idea. In fact, I'm going to. That is going to be my that from now on. I'm going to be using this. Hookers, blow. That is now what we're going to be using. Okay. Of course, his name is already John. That is also true, Prof, but we're going to ignore that. Blow does distort preferences, and then we don't get rational actors, which would make this model better. Prof would know. But, okay. So then, what happens then is we have infinitely many of these level curves, right? So what we can sort of do with these is sort of, we can construct a function, if we wanted to, that sort of maps to each of these indifference curves a number, which we're going to denote with u. So this function, it's u of, let's denote hookers with h and blow with b. And now, actually, Prof, would you like to take a guess as to why I'm denoting this with a u?
Cut out, by the way.
Still alive?
Oh, sorry, Prof. Would
Yeah,
you...
you're back.
I didn't hear you.
Oh, okay, I'm back. Okay, perfect. Prof, would you like to take a guess as to why I decided to denote this function with a u?
Oh, it's a utility function. Oh, sorry.
Exactly.
Should have let Prof answer that.
Yes, so u is essentially, this is the idea of the utility function. The utility function is that you're taking each of these indifference curves, and more importantly, you're just picking a function. It can be any function. We really do not give a shit. As long as this function generates the right set of indifference curves that actually represents the points where he'll be indifferent, essentially all of these points have the same utility, then it's fine. It basically, all it matters is, this doesn't have to be the same as the utility function from utilitarianism in philosophy or anything like that. It just needs to be a function that accurately, like, represents what choices will John make when he can choose between hookers and blow. How much would he be willing to take of hookers versus blow? And we're essentially picking the function so that whenever the utility of some pair of number of hookers and amount of blow is selected, if it has a higher utility, he'll go with that one. We're just going like that. We're assuming that at all points on the graph, the shape of the function is
I don't think we're assuming that. It doesn't always have to look like there's this curve which you draw on the monitor.
No, it could be parabolic if you wanted to. As long as... Okay, so now we're actually going to go over very quickly what the assumptions... Actually, I don't think it can be parabolic, but that's simply because there are sets of... Right, but U0, U1, U2 will all be the same function. No, they do not have to have the same functional form. In fact, it could be just like this or something like that. The only thing is... Okay, so the big rules for utility functions are really these. So, first of all, U0, U1, U2, when you think about it, these functions can't cross. Like, you can never have indifference curves crossing like that, right? Because what you're saying essentially then is... So, at this point, because these are different indifference curves, right? Let's call that U.5, I guess. This curve and this curve, like, they're different curves, right? So they have different utilities associated with them. But if they cross, that means that at this point, they have the same utility function. And so they have the same amount of... for the same amount of goods, you have two different possible amounts of utility. And that sort of, doesn't make sense.
Couldn't you have, utility, areas?
You mean like
let's say you have U0 has, 2 utility, and U1 has 2 utility, but just, differently.
Can you have two indifference curves that map to the same same amount of utility? Like, maybe it goes up and then down?
So,
you mean like if U1 and U2 both have the same amount? Or
well, so you have U1, they're both functions of hookers and blow. And, so you could conceive of some function such that, if you have, you can have different curves that have the same utility, yes?
Yes.
If the utility, the shape of the utility, I forget what it's called. The utility value is coming out of the screen at this, right?
Yes, but I mean, the way I understood it, it's like if U1 and U2 both give you the same amount of utility, then that would be really weird. You could technically imagine such a function, but it would be weird because U2 is technically looking at the U2 on the screen gives you more. It has more hookers and more blow, so it would be weird if it gives the same amount. But you can technically imagine such a function.
But maybe they're not on the screen. But imagine you have one that has okay, you could imagine them having the same utility, even if it would be contrived with the examples on the screen.
Yes, so in fact, we're going to, using the traditional axioms. So the traditional axioms for a utility function actually rule that out. They have something that's, so what we are going to assume actually is something, we're going to assume that happiness or utility as a function of hookers and blow is monotonically increasing, is the fancy word in math for it. But basically it means that as you get more hookers or as you get more blow, you will always prefer essentially you will always prefer a greater amount of hookers and a greater amount of blow to the current amount of hookers and blow that you have. We're going to sort of like make that an assumption. It's also what I like to call the Jeff Bezos doesn't exist function. Where's yours? In this model, there are diminishing marginal... Well, there can be diminishing marginal returns, but yeah, there are always marginal returns. They're always greater than 0. Like, the amount of hookers and blow that you want is... Yeah. So your utility function is assumed to be reasonable. We're assuming the... Yeah, not completely dumb batshit where you just don't want anything more of any... Yes, we can actually... Mond, that is another assumption that is commonly made. More specifically, it's usually made that it's the assumption that's usually made is that it is there is a gradient, so that it's a potential function. A conservative function is usually the assumption that's made. Not for those of you who don't know vector calc, that is not that is not especially relevant for you. But basically, it just means that it's not completely batshit crazy. Yes, Prof. Okay, so for businesses, we are going to make slightly different assumptions later. Right now, we are talking about like a consumer, a person, John, and he always wants more of some amount of goods. This is what's called sort of non-satiation, or like what I was saying, the Jeff Bezos doesn't exist assumption, because Jeff Bezos has so much money that at this point I'm pretty sure he just does not know what to do with it. He's just like out of things to spend money on. But most people are not Jeff Bezos, and this is sort of like a fairly reasonable assumption. Like, I would like it if the economy were bigger and we could hire more hookers and more blow for everyone. That would be great to me. So that is sort of like the second assumption. Yes, you can. That is absolutely... We always want more hookers and more blow. That is the founding assumption of economics. So now I think that we're just going to finish with what utility maximization is, and then next time we'll talk about trade and gains to trade. So now let's think about this, and I will also be here because I will be assigning practice problems that actually involve like actual math. New page. I'm going to be assigning practice problems that involve actual math later, unfortunately, that involve actually working through examples of PPFs. They should be pretty small amounts of math, so you shouldn't be too worried. But now I'm going to talk about basically what utility maximization, how you maximize utility. So let's imagine that John is currently on this indifference curve. We again have hookers and blow. As every Saturday night we do. So let's say he's on this indifference curve. Can somebody tell me why John would not decide to stay on this indifference curve?
Clearly because he can just move like to the right down, and it's going to be more optimal for him because it's like higher in his utility.
Exactly. Yeah, if he moves to this one, he's going to be on a higher... The other assumption that we make about... because we made the monotonically increasing, it technically can't go up like this with the way I accidentally drew it. It has to be always going down. Because that means then that he would get the same, like at this point, he would get the same amount of utility from this point and this point, and at this point he has more utility. So it always has to be downward sloping. I just am terrible at drawing. So it should always be
Wait, so
just,
can I just clarify, so the reason that works is if you draw his successive utility curves, there is a utility curve that's further along, there's an apathy curve that is further, indifference curve, that is further along than the one you initially drew that is still on the line of production. Yeah, okay.
Exactly. So John would never, just be like, oh, sure, I'm just going to stick with this point. No, John is going to get more hookers and more blow. I'm sorry, not more hookers and more blow. He's going to get more hookers and less blow. And in fact, he will, when you think about it, he will keep doing this.
Don't you mean more blow and less
keep
hookers?
moving out. Yes, more blow and less hookers. That is correct. Sorry. And when you think about it, this is a terrible attempt at tangency, but he will keep doing this until this curve just barely touches it. Does that sort of make sense?
Yes.
Yes. And in fact, Mond, this is Lagrangians.
Yeah,
You know
so?
Lagrangians. In fact, anyone else who knows. Yeah, anyone
I
else
don't
who
know
knows
exactly. I didn't hear
Lagrangians.
this kind of a name before, but this is like completely stuff which I've seen before. Like it's.
Yeah, it's an optimization problem. Yeah. So basically, he will always look for a point at which the slope of the indifference curve is equal to the slope of his budget constraint. Under one assumption, which is, and this is an assumption that we are... So there's an assumption that is often made, but not strictly speaking necessary in economics, which is that indifference curves are concave. They always curve like this, sort of inwards. They do not curve outwards like this. And can someone tell me why this process that we just talked about, of having an indifference, of trying to like find the point where the indifference curve barely touches, wouldn't work if the indifference
You
curve
could have
is
2
shaped like
points
this?
if it's shaped the other way. It's concave, convex.
What do you... It is convex, yeah, but like why would we not be able to optimize?
You could potentially have 2 points to touch. Among...
I don't think it's... I think you would need something that's like partly... that's sort of like
The
that.
issue is that the extreme point, the tangent point, isn't the optimal point anymore.
Exactly. This is actually the minimum point. This is the shittiest point that you could be on, because when you think about it, as you go out, this one is further out. And this point right here is better.
Mm-hmm.
Does that make sense? So you need to have this sort of convexity, so that way as you go out, you will eventually get to some tangent point. Sometimes you will see the convexity assumption included for mathematical niceness, because otherwise the solutions are a little bit ugly, because then you'll get something like, oh, the amount of hookers that you should buy is like, you should spend all of your money on hookers, which seems like a very unrealistic result. That like somebody would spend all of their money on just one thing. So sometimes convexity will be included as an assumption for mathematical niceness, but strictly speaking, it's not necessary. You can just check to see which is the better point, because this is what's always going to happen. You're either going to have a concave indifference curve, in which case the best point to be at is like spending all of your money on one good or the other, or you're going to be bitch, you ain't seen me at the store when they got Hearts of Palm. Or you're going to have a convex one, and then there's going to be a point in the middle where these two curves are tangent, and that will be the optimal point. Does anyone have any questions? I think that is good enough for now, and I will assign like a handful of utility optimization problems.
Mm-hmm. That's good.
Wait, I have a suggestion.
Yeah, okay.
Can we have
next time
exams?
we'll...
No, fuck you!